In this video, we'll be discussing the fundamental concept of version control systems, and we'll look at some possible options for building such systems. Many have started by storing their projects or some of their code in different directories. So when a new version was created, we would simply create a new folder and copy the content there. Quite often such folders are named randomly, which results in something similar to what you currently see on the screen. Simply put, we have one single project but multiple versions of it, with tons of different revisions, a final version, and so on. And it's quite often difficult to figure out when a specific version was created, who was the last one who modified it. I mean, sure, you can check the file properties, you can access the security, in other words, check when it was created and who did it. But a method like this is really difficult to maintain, and a system like this is really hard to figure out. The next level we can obtain is using a standard built-in system features of the operating system, which implies sharing the folder via network. Let's imagine that I want to share some of my code with a teammate or a friend. One thing we can do is share some folder of the network and edit it at the same time in the defined network location. But what problems could this lead to? Whoever is the last one to save the file overrides the changes made by the other person. If me and other person are simultaneously editing the same file, the first save will override the original file, and then the second save will consequently override the previous save. And this is completely unacceptable to us, because it won't let us save all the changes made by everyone who is participating in the development of a specific project. We could take a step further and move on using some sort of cloud storage. We could install Dropbox, OneDrive, Google Drive, or Yandex.Disk, but we will still be faced with the issue of file synchronization. This means that when two or more people are modifying the same file at the same time, the system cannot understand which modifications are correct and which are not, namely, which changes are correct and which can be deleted. So the system asks the humans to make that choice. But imagine that we have very many files and we are forced to make such choices daily. This workflow is not suitable for us. It may be applicable for some binary documents, possibly Microsoft Word files or Excel spreadsheets, maybe a PowerPoint presentation. However, it's definitely wrong for working with code, working with programming language files. Let's think in general. What could be the requirements? What could be the goals of a version control system? Meaning, what makes a good version control system and what it must be able to do. The first task that a version control system must solve, it must be able to create some kind of backup, as well as how to restore itself from the backup. The next task that it should be able to handle is the synchronization of work of multiple developers. So if we have 2 or 5 or 50 people working simultaneously on the same solution, we must have the opportunity to work side by side at the same time without forcing anyone to be idle. The next feature that we would like to see is being able to cancel some of the changes. In other words, click Ctrl-Z, revert the modification. If I did something wrong or overestimated myself and decided to continue the next day, I should be able to quickly roll back the changes I have made. And this task should be handled really by any version control system. The next point is the ability to track changes and change ownership, meaning the people who made these changes. I want to be able to clearly understand who and when made specific changes. This can be useful in various situations. Let's say I'm having trouble understanding a certain algorithm that appeared in a specific file in a certain class, and I can very quickly check who wrote this algorithm and approach that person with some questions. Alternatively, if I see there's been a new revision and it's causing build errors, or some other type of problem, I can find the person who did it and scold them. It actually really helps fixing things, helps to understand the revision history, and it's an extremely convenient feature that should really be in every version control server. There are 2 more features that we will probably touch upon a bit later in this training. For now, I'm simply mention them. The first one is sandboxing, is the ability to create sandboxes, which are the type of isolated system which can be used to test something new, something we are not sure about yet. Say we have some folder where we store the final version and would not be embarrassed to show it to the customer or coworkers. And there is a certain directory where I conduct my experiments when I feel like trying something new, a new version of library or some new algorithm, but I'm not ready to share it yet. So I'm not responsible for its quality, but I need some place to store it. And branching is the ability to create separate branches and then to merge them. We'll be discussing it in a bit later. There are many different version control systems out there, and historically speaking, they probably appeared at the same time as programming itself. And if we'll take a look at the market, we will see that these systems can be split in several categories using certain criteria. And the very first criteria we can apply to form these categories is the flow of how exactly these systems work with files. We can define two major popular strategies here. The first one is called lock, modify, unlock, and the second one is copy, modify, merge. In the next video, I will explain the difference and show in detail how each of these strategies work.